Alright, what's up guys? This is Probability by Pitman, Chapter 2, Review Section, Problem number 12. Okay, so in poker, a hand containing face values of the form XXYZW is called one pair. If I deal a poker hand, what is the probability that I get one pair? Alright, this is fairly simple. So we have 13 ranks, of which we choose one. So this one we're choosing is the pair. So we'll have 4 for that pair, for the rank chosen, and we want to choose 4 cards total for that rank. Because each rank has 4 cards. We want to choose 2 of those cards. All right, cool. And then we have 12 ranks remaining since we already chose one of them, and we want 3 of these ranks because we have 3 singles. So for these 3 singles, we have 4 cards for each of the ranks, and we want 1 of them. Let me just cube that because we have 1 for each one. Cool. And then we divide this all by the total number of hands possible, which is 52 to 5. All right. That was fairly simple, I think. So let's do part B. Okay. So if I keep dealing independent poker hands, write an expression for the probability that I get my 1/50th one pair on or after the 400th deal. So that's equivalent to getting your 149th pair, or getting 1 pairs or less on your first 399 trials. Yeah, okay. So once again, probability of getting 149 pairs or less on your first 399 trials. So you'll recognize that they're just asking us to write an expression. That makes this a lot easier. So that just means we're going to write some sort of summation expression. So just right off the bat, I'll write I equals 0, and it goes up to 149 because we want to sum up all the probabilities of getting 0 success, 1 success, 2 success, all the way up to 149 successes, where success is defined as a pair of, or as a 1 pair, which I guess I should have wrote here. 1 pair. Okay, so you'll recognize that the probably getting each 1 pair, or each trial, of which there are 399, is an independent Bernoulli trial, with probability of success being the probability of getting a 1 pair. So call our answer, which is the probability of getting a 1 pair in part A, as P of A, and so we'll just construct some sort of binomial trials. So we have some sort of binomial distribution. So we have 399 total trials, of which I are good. Our probability of a success is P of A, and we have it to the exponent I because that's the number of successes we have. Then our probability of failure is just 1 minus P of A, and then the number of failures is just the number of trials minus the number of successes. So if we have 399 trials, we have I successes, then the number of failures is 399 minus I. And that is our answer for part B. Can you believe it? That was pretty easy. Okay, cool. Making these problems a little easier towards the end, I guess. The review section. It's interesting. Okay. See, approximately what is the value of the probability in B? Alright, coolio. So, obviously, actually calculating this is hella annoying. An easier way is to just use a normal approximation, which especially becomes a more obvious route when you realize that this is just a binomial distribution, right? It's super easy to normally approximate that. So for normal approximation, we need mu and sigma. So we know there are 399 total trials, and a probability of success is P of A. So remember, mu is equal to NP. Sorry, I forgot to say that. So that's N and that's P. So whatever this is, we'll just call it mu because I don't want to write that shit. Okay, cool. Sigma is equal to root NPQ, which is equal to root 399 P of A times P of A complement. Once again, I don't want to write that shit, so I'm just writing sigma. Okay, cool. So, remember, we want to find the probability of 0 to 149 successes. So that's a normal curve, and let's say 149 is here. It might not be, I'm just writing it there. We want this shaded area. So, I think, oh yeah, so it's just, we're doing CDF, right? So, if we use a CDF phi function, we're just getting that entire area. So we just need to do phi for 149, which is super easy. Cool. This makes me happy. So it's just 149 minus our mu, then all over sigma. And then now I'm realizing I guess they want us to use corrective factors. If that's the case, it's really not that much harder. You just do 149 minus or plus half minus mu all over sigma. Then you subtract by phi of 0 minus half minus mu all over sigma. And the reason I did it like this is because you're finding the area between 149 and 0. You just, or any other number, you subtract the leftmost number, the phi of the leftmost number from the phi of the rightmost number. So we're just doing the CDF of both and finding a difference. You'll see that they'll basically have the same answer. It'll be slightly different because of these corrective factors. But both of these answers should be correct if I am not mistaken. Alright, cool. Thanks for watching, and I hope that helped.